So, how's everyone doing? I hope after a day full of talks yesterday, we are all ready for another 2 days of conferencing. So, to begin with, I'm here to talk about quite a bit of things in there. There's the title says "Not Invented Here" syndrome, and Dr. the PagerDuty story. So, let's kind of dive right into why we are here. So, the title of the talk is actually full of quite a bit of things in there. There's some jargon thrown. So, what I'll be doing in the beginning of this talk is dissecting those terms and then looking at a case study and seeing how sometimes custom software that's developed in-house can lead to dark debt and how we can reduce that dark debt. So first, let's begin with not invented here syndrome. What is not invented here syndrome? Oops. Okay, so the English Wikipedia defines the not invented here syndrome as the tendency towards reinventing the wheel based on the belief that in-house developments are inherently better suited, more secure, and more controlled, quicker to develop and incur lower overall costs than existing implementations. Now, what does this mean? This means that sometimes as programmers, as developers, as SREs, we feel that our use cases, the scenarios, the problems that we are trying to solve is unique in its own regard. This means a lot of times, despite of the presence of an open source solution or a vendor that provides some form of that particular solution, we end up reinventing the wheel, assuming that our use case is a special one. So that's kind of a cliche definition. What's dark debt? Dark debt is a relatively new term. This was coined in the Stella report from last year. And to read out the definition here, the dark debt was named to draw a parallel with dark matter. Dark matter has detectable effects on the world, but cannot be seen or detected directly. Dark debt is found in complex systems, and the anomalies it results are complex system failures. Dark debt is not recognizable at the time of creation. Its impact is not to fall development, but to generate anomalies. That's a lot of terms in there, right? Now, let's try to compare this with something that we actually know, or something that we have actually heard about before, technical debt. How does this compare with technical debt? So, to take a step backwards and actually just think about it for a second. Technical debt is the type of debt that can be solved by refactoring. On the other hand, dark debt is something whose sole purpose is to add anomalies to an existing system. Dark debt is the product of complexity. As complexity grows, the dark debt in a system grows. And its presence is actually felt in the form of complex system failures. So every time there's a major incident at your system, there's a pretty good chance that it was due to some amount of dark debt that had accumulated over some period of time. Another question that this talk aims to dissect is the build versus buy question. Unlike the bygone era, where buy actually meant buying a piece of software and developing it and deploying it inside your company's firewall system, buy in the modern sense could mean using an open source off-the-shelf solution, or in other case, using just another SaaS or a PaaS vendor. But how does this relate to dark debt? Where does this fall in line with the not invented here syndrome? And can building instead of buying lead to dark debt? These are some key questions that I aim to answer in this talk by means of a case study. And like I said, where does the not invented here syndrome come into the mix? So let's dive right into section 2, which is the case study. This case study is called Work Queue. October 24, 2011. It was a day like any other day, a very fine, foggy day in the city of San Francisco. In a company called PagerDuty that was roughly of 20 people, a group of engineers decided to build a custom, in-house, distributed queue. Now, it sounds like an overkill. Why would a company of like 20, 25 people in its really early stage try to build this thing? What were some key motivations behind building a custom distributed queue in a small company? So by means of this case study, we will see how work queue was born and how it was killed as well. So the result of that fine day's meeting of October 2011 was something called work queue. So work queue was the in-house solution to build a distributed fair partition queue and task scheduler that uses Apache Cassandra under the hood. A lot of this talk will be about work queue, its background, the reasons that it was built, how it added darknet into PagerDuty's system, and how it was ultimately killed. So let's look at the background regarding the requirements of what were some key drivers that led that early group of engineers to develop work queue. The first one was high availability. So makers of the work queue wanted a really highly available queue that would actually withstand not just region failures, but also vendor failures. The underlying idea was very powerful. The notion was that even if one cloud provider goes down, PagerDuty should still be able to deliver your notification. And the way this problem was solved was by trying to come up with this resilient queue that would not fall apart even when one vendor went down. The other key requirement behind the development of work queue was durability. So the concept of durability comes from the relational database management systems, in which it means that even if the system reboots or there's some power failure or any other reset of state, the data that was there, that was committed to the work queue, will still be around. So therefore, durability was another key requirement that was trying to be addressed with the development of work queue. The next one, now it's kind of, I think, taken for granted, but back in 2011, for a small company, this was, again, a very big requirement: high scalability. The idea behind high scalability was that whenever the engineers in the company wanted, they should be able to scale work queue up or scale it back down just by adding or removing a node. Decent queryability. This meant that at any given point of time, someone using the work queue should be able to get the data that was present in the queue just by looking at the data and querying it, rather than consuming from the queue just by looking into it. Almost like querying a relational database management system. Flexible schema. Since the queue was actually developed in order to satisfy the storage as well as delivery of customer data, which was by definition unstructured, it had to support flexible schema, meaning that it had to be schemaless, and any sort of data that came into the system should be queuable as well as usable by using work queue. Another key requirement was backups. Work queues, because the requirements around work queues were work queue was high availability and resiliency, another thing that came in hand was backups, in the sense that the makers of the system felt that the queue's content should be dequeuable at any given point of time, stored in another storage medium, and then it should be able to be rebuilt from scratch in the event of any catastrophic failure, that is. And here's my favorite requirement that came with the design of work queue. It was synchronous replication. Synchronous replication, as we all might know, as people who work with distributed systems, is a peril. Synchronous replication is something that adds in a lot of additional complexity to our already complex systems. But why would a company that is quite small choose synchronous replication as a core requirement for its core notification delivery system? The reason was, again, very simple. It was in order to handle a vendor failure or a cloud vendor failure, synchronous replication had to be done across multiple data centers spanning multiple vendors. And this was being done synchronously across an encrypted public WAN. So those of you who are familiar with networks would know that this was definitely not a good idea. But this was still being done, and this was one of the key requirements for this work queue system that was about to be developed in 2011. So with all of those requirements, what were the options then? In the beginning of this talk, I talked about the build versus buy question, about not invented here syndrome. But back in 2011, for a company that had these requirements, for a team that had to build software to address these requirements, what were some options? To quote Theo from yesterday morning's keynote, Apache Kafka is a queue that usually comes in mind when we talk about these requirements, or a subset of them. But this was 2011. LinkedIn had barely just released Kafka in the open source ecosystem, and there was no real ecosystem around it back then. It was barely another open source project that had just been open source. It was not really stable for the use case, so Kafka was just not in the picture then. But other options were actually considered. Some options that were considered were Apache Storm. Well, not exactly Apache Storm for its traditional use case, but a version of Apache Storm. Another thing that was considered was using an event-driven framework to write and to do this processing in a different event-driven way. Some other options were also considered before the choices were actually made. And while options were being considered, there were also options regarding the database that were considered. And rather than going with Cassandra, the team also felt that Riak or MySQL could have been used as the database layer. But given the familiarity with the JVM ecosystem, Cassandra and other related technologies were chosen. And the result was WorkQ. The version 1 of WorkQ was born. This was a year later, in 2012. How was it, if you may ask me? It was great. It was fast. It addressed all of those problems. It did what it said on the tin. And it was probably the best way a company could deliver notifications in a resilient manner. But that is not what I'm here to talk about. I'm not here to talk about how WorkQ was the best solution for our problem. The reason is we almost developed a software that did one thing and did it well. But we didn't stop there. Along the way, we made some mistakes. That is what we are here to talk about. The first thing was we started with a queue that did something very simple. It took in some data, and it was being dequeued off the queue. But soon, we started to feel that it needed something better. It needed something extra. And the first set of additional feature that was added to this queue was called the host-based partitioning, which meant that every single consumer was a host, a Linux running machine that was consuming off of this queue. And the underlying idea was that every time a new machine was added or another consumer was added, it would get partitioned. So every consumer can sort of consume from the queue in its own way. Think of this like a very poor man's way of doing consumer groups like Kafka does, but in a different semantic scenario. After this came fair partitioning. Since WorkQ was being used to send in data outside, and all the data that was being enqueued into the queue had its own priority, which is all equal, fairness was a key requirement. So the way this was implemented was by using a series of queues, in the sense that every single value that got into the queue got its own queue. Sounds like a very complex thing, right? The reason is that it was actually pretty complex to implement. The next one is time-based row bucketing. By this, it means that we needed some sort of temporal way of querying the data based on time values. Yet again, our simple queue was now full of another requirement, and we ended up adding another feature to it. But that is not it. What ended up happening was, rather than just that one particular use case that was supposed to be using WorkQ, there were more and more internal services within the company that were using WorkQ. The result was there was a Cambrian explosion in the number of internal services that were supposed to be using an open source alternative or building something else using this one homebrewed library that was supposed to do something else. And now, there, we had it. That original piece of software that was supposed to do one thing well, and doing that, except that one thing, what it was now doing was it was doing 5 to 6 different things, and it was not doing any one of those well enough. In the meanwhile, outside PagerDuty, in the world, a lot of things had changed. The first one was that distributed queues like Kafka had gained an immense amount of popularity and support. and a community. And this meant that going back to that original set of requirements that included things like high availability, resiliency, and all that, those are now being addressed by these open source alternatives outside the company. PaaS-based queues were actually making their presence felt. So Amazon's SQS, Google's Cloud PubSub, and Kinesis started to become more and more stable and widely used. So for the same use cases that we were not using those queues, now there was some amount of justification that those queues could have been used as well. Sadly, Cassandra's API has changed. Around the time WorkQueue was built, this was around 2011, the original version of Cassandra being used was 0.8, and WorkQueue supported up to 1.12 version of Cassandra. Unfortunately, as Cassandra's API rapidly changed, WorkQueue could not keep up with it. As a result, WorkQueue's compatibility with Cassandra was broken, starting newer versions of Cassandra. Even more importantly, the same set of technology choices that we made, which led us to choose Cassandra and Thrift RPC in the sense of minimizing several amount of load, was now falling out of favor within the company itself. So there, we had it. WorkQueue's nature and widespread use was slowly turning into a different set of dark debt. And like the Stellar report actually suggests, dark debt makes its presence felt by showing in the form of anomalies in the system. And that is what happened. Here are some screenshots of some postmortems and some major incidents. If you look at the details in these postmortems, you would actually see the word Cassandra being mentioned several times. You'll see that a lot of this had come from that brewing of dark debt, which had to do with WorkQueue. So in these years, while the original set of requirements did not change and open source ecosystem caught up, the in-house software was not able to catch up, and at the end made its presence felt, like in the sense of incidents, major incidents. Let's move on to the section 3 of this talk, which is lessons learned from this case study. First, the first lesson is that the dark debt is actually a product of complexity. As we had seen with WorkQueue, what started as a simple library to do this one task of resilient distributed queuing had now evolved into this wide plethora of several services which had their own requirements. So as complexity was added to the system, so was dark debt. So therefore, its maintainability had gone down. And as a result, these anomalies had surfaced several years later. Having said that, just a disclaimer from my side, the development and use of in-house software for a task is not directly an indication of dark debt. That's also something that the case study actually says, because WorkQueue, when it was developed, was great and it did its task pretty well enough. So just the development and use of in-house software is not an indication of dark debt. However, the proliferation of such special purpose software to other areas is often an indication of not invented here syndrome. And not invented here syndrome is a very strong indication of dark debt. And how can we get around this problem? Well, proactive evaluation of past custom solutions before their proliferation throughout the organization could help alleviate some of these problems. Had we taken a step back and looked at the ecosystem that was being developed outside, we could have gone back and maybe used those tools instead of using this custom solution that was being built in-house. And here's another one. Unless you're 1% of the companies on this planet that actually have a use case to go with build, do not go with build, unless there's a really strong use case for this. So therefore, the asterisk there, conditions apply. And when in doubt, always choose simplicity over complexity. Complex systems fail. Complex systems are hard to maintain. Complex systems are hard to debug. So do not go with complexity. Choose simplicity. And that is how one can address dark debt that is brewing in one's systems. Epilogue. You might be curious what happened to WorkQueue. Is PagerDuty still using WorkQueue? Will it be open source? why was it not open source? So this is the part in which I sort of try to answer those questions before they actually pop up. The official support for WorkQ was ended in 2016. So the team within PagerDuty that maintained WorkQ stopped supporting it internally in 2016. The Cassandra-based WorkQ's usage in PagerDuty has significantly reduced since 2017. There's almost one system, and I say almost because there's a part of one system that actually uses this as of now, but that will be going away in the next couple of months. So there, we started building a system back in 2011 to support some of our use cases around distributed task scheduling, as well as around distributed resilient notification delivery. And in 2017, we found out that other off-the-shelf solutions were better, and we started moving off of it just because we saw the presence of dark net being felt. I hope at the end of this talk, we all walk away with some food for thought around when should we stop what we are doing, take a step back, look and reflect around the use cases for the software that we are building, and try to see if we can go with simplicity instead of going with complexity. And in order to kind of stop my talk here, I'd want to quote Dijkstra as I leave stage. And here's one of my favorite quotes that I think one can relate pretty much all the time in software. Simplicity is a great virtue, but it requires hard work to achieve it and education to appreciate it. And to make matters worse, complexity sells better. That's Dijkstra. Thank you.
Questions?
On the right.
At one point you said that one thing to do could be to reevaluate your solutions every so often, but would you really have the courage or the guts to say, like, a year in, of your product as it's like kind of taking off, that, well, now there's an open source solution, let's switch and kind of cut this baby off now, or cut our losses? I mean, what I think it would take a lot of courage to stop that. What can you comment on that?
Okay, so if I got the question correctly, was it around at what point of time do you stop doing what you're doing and go back and reevaluate some off-the-shelf solutions?
Sort of, and when you reevaluate off-the-shelf solutions, I mean, would you have the courage to really, like, 3 years in, everybody's excited about the thing taking off, and say, okay, now we're going to stop it and we're going to take this open source solution?
I think that's a very valid question, and I think we have gone through those phases while working on WorkQ. I believe, based on my experience, there's no right answer that this is the point of time where you go and make the switch. I think, like most projects, this is something that should be driven by data and by experience. So most likely the preferable way here is to, rather than going and changing things in some things you have already used, maybe for a new use case, rather than adding more complexity to your existing system, you start with something with a clean slate and then go and see how things work there, and then maybe retroactively come and apply those things to an existing system. Does that answer your question? Thanks.
So one of the approaches, or what I tell my teams often, is kind of, okay, either you think from the start about open sourcing it, or it's this arms race, right? So you just have to wait for something better to be open source, and then your internal project is basically kind of obsolete maybe. So is this kind of affecting how you deal with dark depths and say, look, if this is not to be open source from the start, it might be kind of this dead-end internal project, and something better will come along from another org, and then ours is kind of to be decommissioned or switched away from? Okay,
first, the audio here is a little bit weird when someone talks on that mic, so if I were to repeat your question, and feel free to correct me if I'm wrong, if I didn't get the question right, is your question around the fact that had WorkQ or is it a good idea to sort of open source a custom solution so that there could be an ecosystem around it from the beginning?
Yes, to kind of address this dark depths from the start to say, like, if this is not a product we would open source from the start, or have it already built in that this would be an open source community effort, that this is kind of always potentially dark depths, because we just have to wait for someone else to build this in the open, and then it's kind of a dead end. Okay,
so I think to add to that question, or to sort of answer it, at least for this particular case study, given the size of the company, I think this was very early to maintain an open source project or to help develop that ecosystem. So in this case, it was clearly not something very obvious and easy to do. But I can sort of see in bigger organizations that is probably one of the outcomes that is possible. But given the size of the company and the stage that it was in, I don't think that would have made like a lot of sense there.
Okay, so before in this room there was a talk, Halt and Don't Catch Fire, which was talking about the startups and SRE teams in startups. And then there was a point about not using immature, not tested, hot new software. So what to do in that case if there's Kafka is super new, you don't know if it is going to live more than a year, but don't build it inside. What to do?
So I was not actually in that talk, so I won't be able to give maybe like a fully justified answer. But based on the question, I feel like it's again something that has to be done in a case-by-case basis, and there's no like one answer that fits all.
I guess sort of continuing on that a little bit, it's October 24th, 2011, a foggy day in San Francisco. Knowing what you know now, what would you have done?
That's a really good question. So if I were to like go back in time and like go and build those things, I think one thing that I'll do is I'll go and ask do we need to check all of those boxes? Does it really mean that we need to check all of those boxes and those requirements, right? Because we had some requirements in there which was like synchronous replication and like vendor failure, which seemed like really absurd, right? So maybe if I were to do it, go back and build those systems again, I would go back and see if all of those requirements had to be made, like checked off, and if not, maybe go with something else that maybe gives me like a 70% compatibility, in the sense of like trading off between maintenance against checking all the requirements off.
Any other questions?
If there's no questions, I will be hanging by the PagerDuty booth right outside, so you can all, again, like come and ask me any questions that you have. I'll be right outside this door.